and you're more than welcome to look through them and have they're very pretty books. So this small study, pro bono study, worked into a 300-page book. And I also have some brochures that synopsize the whole thing, which makes it a lot easier to digest. So let me just start. So when we started it, it was a time when the city of Chicago was putting together a climate action plan. And they had a lot of strategies for reducing carbon, but not strategies, but they had a lot of goals. And we felt the strategies weren't clear, particularly for buildings and the loop. So we started developing some strategies. At the same time, the AIA, which is the American Institute of Architects, had their 2030 commitment to provide carbon-free buildings by 2030, or sorry, basically zero energy carbon buildings by 2030. So at the time we were working on the Sears Tower, I'm sure most of you know the Sears Tower. It's now called the Willis Tower. It's about 115 stories in downtown Chicago. And that client had asked us to make that building, reduce the energy use in that building. And we felt that through a series of strategies, we could reduce the energy in that building by about 80%. And that included some hydrogen fuel cell technology as well. So it wasn't just reduction, but it was energy production. So there's 550 buildings in the loop in the central business district. And so the city said to us, well, if you could do this to the Willis Tower, the Sears Tower, could you transfer that across the 550 buildings in the loop? And so we took a stab at it, and knowing full well that our firm is known for designing zero energy, high performance buildings, but you can't destroy existing buildings just so you could put a zero energy building up in its place. The carbon never balances out. You can save all the energy you want, it still will not because of the embodied carbon. So in a building like the Willis Tower, we have 1,500 miles of electrical wire. Like the carbon footprint of that alone, let alone all of the steel and so on, and trying to demolish a building in the loop would be insane. Modernization is really the only way to go with all of those buildings, most of those buildings. So we did a lot of experimentation work with the Willis Tower, and one of the most interesting things is we wanted to see, could we have a green roof on a super tall building? So this is actually, the photo on the left is a little mock-up demo project we did of a green roof on the 100th story of the Willis Tower. And you can see there's some pretty heavy-duty cables holding that thing down. But we installed that 5 years ago as a demonstration project. It's about 2 meters by 5 meters. And it's growing quite well at that height. And it's the tallest green roof in the world, really. But one of the reasons we knew it was doing well was the second year it had ladybugs in it. And that's always a sign that things are growing, right? When you get bugs in your green roofs, it's good. It's a good thing. So to look at the loop and to reduce the carbon in the loop, everybody likes photovoltaics and wind farms, but they're really not very practical, and they're very expensive. So if we wanted to offset all the energy used by the buildings in the loop, we were going to have to create a rotating solar farm out in Lake Michigan. So you can see that tiny red dot in the first top image is the Chicago Loop. And we would have to create a 20 square mile, I forget what that is in kilometers right now, out in the middle of the lake. And that would be like a cost of $27 billion. So obviously just creating solar to offset the energy we use in the loop is not really efficient. And the same with a wind farm. We could do a wind farm for $2.7 billion, and that would take about 210 square miles. So those are just not viable solutions. You really need to look at energy reduction. So this is just a little slide I added in from yesterday that sort of looks at energy systems and how we look at things in our office. The top slide shows the way old technology. You have an energy plant, that's coal or nuclear, and then that power is transmitted to the buildings. And there can be up to 80 to 90% loss in energy transmission. So you've got a lot of wasted energy. So then sort of new technology is really still kind of an old, using the old distribution philosophy, right? So you create, energy through wind or solar, which is clean energy, but then you're still shipping it to the buildings. And there's still that potential for energy loss. And so this sort of new technology, that something that we try to look at in our office more and more, is this idea of the buildings creating the power so that you don't have that transmission loss. So that's just a little strategy we look at in new projects that we're working on right now. So back to the loop and the decarb plan. I felt really strongly that just looking at buildings alone wasn't going to reduce the carbon, that we really needed to look at other elements. And I believed that there was a synergistic relationship between other strategies that would create greater carbon savings and thus better quality of life for the inhabitants of the loop if we looked at things together. So the diagram on the it's on the right, it shows this idea of synergistic relationships. And we looked at different elements, not just energy in buildings, but mobility, transportation, waste, what else do we look at? Waste, community engagement, mobility, water, waste, smart infrastructure, and density. Actually, density was a really big one. Density, I'm calling urban matrix. And so the bar graph in the very middle shows this sort of countdown in carbon. So we knew that the loop, or the city as a whole, uses or creates about 39 million metric tons of CO2 emissions per year. And the loop is responsible for about 10% of that. Even though it's only 1% of the land area, it's 10% of the emissions. And that's because of the density of the loop, all of those tall buildings. Excuse me. So here's the decarbonization plan as it stood, with all of these different strategy areas that we wanted to look at. So buildings, urban matrix, which is density, waste, smart infrastructure, water, mobility, community engagement, and then clean energy. And then funding, it all had to be tied together and funded in some way. So this was the strategy for that decarbonization plan. And this book is divided into those chapters. So we really wanted to find synergistic relationships between those two that would give us greater carbon savings than just looking at them in silos individually. So I'm going to focus just on 3 parts, which were my favorite 3, or buildings, urban matrix, density, and community engagement. The other ones, we had engineers. We had a large team working on this project, and we also had some engineers that looked at the items such as waste and water and smart infrastructure. So these are more the architecture, urban design ones that I'm going to focus on. So we knew that 90% of the buildings in the loop were built before 1975. So that meant that all of their equipment was coming up for replacement. It's over 30 years old. So it was a good time to start looking at the buildings in the loop and looking at strategies to reduce their energy. And really, new buildings only account for 1% of a city's building per year. So it would take us 100 years to replace all the buildings in the loop. So we really have to look at the existing buildings. Next, I'm going to show you a little video. And hopefully it's going to run. Sometimes it needs to buffer first. So we might have to give it a second.
Just wait?
Yeah, we can just wait. I can talk about it while we're hoping that it's going to start. This is a little video, and what we created was a parametric model, which is it's a database tied to a 3D model. And we were able to survey a lot of the buildings in the loop, those 550 buildings, and collect data from them on their energy usage, number of parking spaces, the size of the building, the age of the building. And we're able to put all of that data into the database and then tie it to this 3D model. And the idea of the 3D model, the parametric model, is that we could change the parameters. We could change, we could zoom in on one building specifically if we wanted to, and say, what would happen if we changed the glazing on this building to double glazing? Or if we re-insulated the building? How would that change its energy usage and thus its carbon usage? Or we could look at the whole city, the city as a whole, and say, what if all of the entire city recycled all of its paper, or the loop recycled all of its paper? What would the carbon savings be for that? I don't think it's going to run.
Did you click on it again?
Oh, well, maybe that's it. I've never used that, done that before. Let's try that. Oh, no, that just goes forward. Yeah. No. It's a quirky little program. Sometimes it runs and sometimes it doesn't. We were just lucky yesterday that it worked. Yeah.
It's impressive because you can actually
Yeah.
see the different proportions of things, what will be
Right.
the most efficient
We can
action.
try it later and see if we
Okay.
can run it independent. But as Eleanor was saying, you could zoom in on, my demonstration zooms in on one building. It picks the Aon Center, which is a big building in downtown Chicago, and changes the glazing. And as you change the glazing type, and you can change the film inside the glazing, and it adjusts the carbon immediately and shows you the different carbon and energy savings thus, if you change the glazing on that building. So it's a great tool, not only for the city to know how it could, as a whole, to know how much energy it could save, but it's also a great tool that clients, you could use with clients as well. So you could say to the client, well, if you change all your glazing, this is how much energy. And eventually we'd like to be able to input the cost of that glazing as well, so we could give the client the return on investment, so they would know it's going to take me 5 years to pay that back, but is that worth it? Is that worth it? All right, it's not going to run. So one of the other things we were able to see with that model is we could break down the buildings by year they were built. So, you can see here it's, can't read this without my glasses. We're able to look at the buildings in the loop that were built, sort of the heritage era, which is 100 years old or so, up to 1945. We were able to look at the mid-century modern buildings, get an idea of the post-energy crisis buildings, and then the energy-conscious 2000 and on. So we had a good mapping of when all the buildings in the city were built. We're also able to input things like vacancy rates, so we could tell which buildings are vacant and are potentially, good buildings to renovate, which I'm going to come to in this next part. So the urban matrix idea is this idea of density. Very few people live in the loop. Currently, this is the status of the loop. 10% is residential and 90% is commercial, pretty much commercial. A little bit of institutional in there. And so, carbon emissions of offices is about 4 times the carbon emissions of residential. And so we have all these buildings in the loop, commercial buildings, and a lot of them are sitting unused. And so could we possibly, when I was talking about synergistic relationships between the different elements, could we possibly, what if more people lived in the loop? That would reduce the mobility carbon footprint, because you have a lot less people commuting into the city. Excuse me. And then we have all these empty buildings in the loop that we could use as residential. So currently it's only 10% residential. So what if we bumped it up to 25% residential? Now, one of the issues with the loop is it's missing a lot of amenities that people need to live there, such as schools, daycare, grocery stores, green spaces. So we, pardon? Okay. So we could bump it up to 40%. You can see we start to change buildings to mixed use, and we also added green roofs to the top, living spaces to the top of some of the buildings, and we went up to as far as 50%. And you can see we started adding schools in there and other amenities. So this idea of potential reuse of buildings, using that parametric model, we're able to tell a lot of the buildings where there's a high vacancy rate. And this one is a great example. It's a turn-of-the-century building that's sitting 40% vacant at the moment. But you can see from that floor plate, it makes great living space because you can get daylight. It's a very narrow floor plate, and it also has operable windows. It doesn't make a lot of sense for office space anymore because the floor to floor is too low. You know, you need computer cabling and all kinds of other electronic access that old buildings are just not built for. So it would make a great residential space. And you can see the top drawing is the roof plane, looking at creating an outdoor space at the roof level. This is just showing that idea of taking the loop and dividing it into neighborhoods and making sure that each neighborhood has those amenities, schools and daycare, places to grocery shop, outdoor spaces. This image is just showing this idea of this mixed use. Can we take a building and make it resident or commercial at the bottom levels, then residential, and then possibly the schools at the top level? And that ties back into that idea of quality of life, creating a better quality of life, that you're not commuting to get your children after school or rushing home. You could actually just meet them for lunch if you work in the same building as you live in, that they go to school in. And then mobility, that was another big chunk of the carbon. So we looked at, you know, all the different, we wanted to track all the different kinds of mobility in the city. And I specifically call it mobility instead of transportation, because mobility to me means, you know, ease of getting around, and it doesn't necessarily mean vehicular, right? It means walking, it means bike shares, it means one-way car sharing. So we started like mapping all the different transportation systems in the loop, different ways of getting around the loop, from buses to taxis to trains, different types of train, regional trains and local trains. And we also mapped the underground pedway system, which was quite disconnected, and that's the pink pieces that are showing up on that map. And you can see that the pink lines never connect to each other. So we got really interested in the idea of connecting all of those underground systems, those pink lines, all the pedway systems, and connecting those together, and thinking of, in Montreal and also in Toronto and Minneapolis, there is great underground or above ground connected pedway systems, and they have similar weather, very cold in the winter, very hot in the summer, very similar to Chicago. And those pedway systems are really effective, whereas the one in Chicago is disjointed and quite scary at times, actually. You can end up in dead-end spots and water dripping down and all kinds of things. So we thought there's potential there for the building owners along those pedway systems to buy into recreating that, connecting all of that system together. And then we kept finding right across, there was no connection from the east to the west across the city. From the west, the two train stations, right across the loop, there was really no connecting piece of infrastructure, transportation infrastructure. So we created what we called a green axis, intermodal green axis. And the street is currently about a 4-lane street. This is it here. And we've narrowed it down to 2 lanes and made this green pathway along it. So there's only room for taxis and bike path. And so we had this vision of this being this, you know, above grade, beautiful green way to get across the city. But below grade, we created an electric bus line below grade. And you can see that there's openings in that bus line, so you could still get to have access to daylight above. And it, you know, if you have more people living in the loop, now you have a need for this to be 24/7 access. So during the day, it's sort of like this. Then at night, it's more, you know, it's still active at night as well, because you have more people living there. And then the community engagement portion, to me, was very important. There's studies that have shown that community engagement can reduce carbon in a city for anywhere from 3 to 15% based on you know, education, basically. So we looked at, some of the ideas we looked at were creating a Green City textbook. We currently have the Wacker Manual, which is based on the Burnham Plan. And that Wacker Manual over 100 years ago was given to all 5th graders in Chicago. And it's amazing, you know, it was really, the idea of Burnham Plan was to give the city back, from the industrial age, give the city back and the lakefront back to the occupants of the city. So we thought, what if we created a Green City Manual, which is in the sustainable age, and educated people through that, through the schools. It's kind of amazing in Chicago how many taxi drivers can tell you about the Burnham Plan, and that's why, because they were all given this book as you know, in 5th grade. Some of the other things we looked at was possibly, you know, we currently have a beautiful green roof that Michael's going to talk about later on today. But what if part of that green roof became an urban agriculture garden instead? And those vegetables were sold down in the marketplace. We currently have a marketplace at the foot of that, across from that building. And that would be a great way to sort of educate people on urban agriculture. So now what? You know, we created this plan. We finished it about a year or so ago. And it's really a book of over 100 pilot projects. Now, you know, the city of Chicago is pretty broke, and how a lot of these projects are really expensive. So we're sort of stuck at a point where we don't really know. We're not sure how we can move some of the bigger ideas forward. So what we're doing currently is working with the city on commercial building retrofits to reduce the energy use in buildings, slowly picking away at pieces of the plan. The community engagement, you know, we're teaching a course at IIT based on the decarb plan that educates more people about the ideas in the decarb plan. And we also have an exhibit at the Chicago Architecture Foundation based on the decarb plan. So we're slowly getting parts of the plan moving forward. So, and the book actually was a great thing as well. And we've been able to get a lot of work because of the book, which is great, because we did do the project pro bono.